Welcome back. In the previous session, we saw some simple digital filters. Now, in this session, what we'll do, we'll plot the frequency response of those simple digital filters. All right. So let's start. Now, let me share what we did in the previous session. We said this is a low-pass filter whose impulse response is this, and the transfer function of this in Z domain is this. Then we obtain the frequency response R, the discrete time Fourier transform of this by substituting Z equal to e raised to j omega, and the difference equation that describes this low pass filter is this. Same way the high pass filter is impulse response to this. Z domain transfer function is this. Frequency response is this, and the difference equation is band pass filter is this, and it is Z transfer function is this. It is discrete time Fourier transform this, and finally this is the difference equation that describes. Same with the band stop filter, right? As these equation. Now what we try to do? We try to plot these equations of these filters, right? From 0 to pi. That we will do. Right? We'll try to plot h of omega of these expressions. All right. Now let me switch to MATLAB to do that. All right. So let's switch to MATLAB. Okay. Now what we'll do? We'll plot this on a single window. All right. So we'll try to do that on a single window. I hope you are able to see this. So then we'll try to use fplot command of MATLAB. So fplot, we'll say ABS 0.5 multiplied by 1 plus, first we'll try to plot the low pass filter, exponential of e to the power of minus j omega, e to the power of minus j omega, 1, 2, how many bases? 3 bases. Then we'll say omega is varying from minus pi to pi, and we'll set the line width. Let's suppose the color. Let me set the color as red. Then line width is, let me set it to 3, and then what we'll do, we'll title this, we'll say this is an FIR low pass filter. This is an FIR low pass filter. Then what we'll do, we'll on the second window, what we'll try to do, we'll try to plot the high pass. When the difference between high pass and low pass is only there is minus here. All right, and the color that we'll use now is blue. So this is blue, and we'll try to put a title there. Sorry, the title should be high pass, not low pass, but high pass. All right, so this is high pass. And then we'll go to the third plot, and on the third plot we'll try to plot this one. There is band pass, and there is 2 here, so it is multiplied by 2, and the color that we'll use red, but this time we'll use dash. Alright, then what we'll try to do, we'll try to put a title. Let's say this is band pass filter. So I'll say this is band pass filter. Then we'll go to the fourth plot, and so we'll set this, and there is minus here. I think I have done it wrong. This is band, this is actually band stop, and this is and then this is actually band stop. So it's band stop. Let me go back to this. There is minus here. The rest will remain same. And let me show you the window. Right now, have a look. See, this is indeed the low pass filter, FIR low pass filter. Why? Because at omega equal to 0, the magnitude response is 1, and at omega equal to pi minus 3.14, the magnitude value is how much? 0. Same way, this is a FIR. I hope you are able to see this. Okay, let me show. This is the screen. Alright, so this is an FIR low pass filter. You can see at omega equal to 0, the magnitude is 1. At omega equal to pi, the magnitude is 0. You can check. Right, same way here. This is an FIR high pass filter. This is an FIR high pass filter. Now, as you at omega equal to 0, the frequency response is 0. At omega equal to pi, the frequency response is 1. So this is allowing higher frequencies to pass. Right? Now, FIR band pass filter. Now, let's consider the positive frequencies only. So from 0 to pi. As you can see, this allow at omega equal to 0, the magnitude response is 0. At omega equal to pi, the magnitude response is again 0. So it is allowing the inner frequencies to pass, but rejecting the higher, lower and higher frequencies. So this is a band pass filter. Same way, now this fourth plot is a band stop filter. How? If we consider the frequencies from 0 to pi, right? So 0 is the minimum frequency, pi is the highest frequency. It is passing low frequency as well as high frequency. You can check the magnitude response is 1 at low as well as high frequency. But at some frequency, the magnitude response becomes 0. So it is rejecting some band of frequency. So it is rejecting some band of frequency, but allowing lower and higher frequencies to pass. So I hope you have got the idea that these, yes, indeed, these are low pass, high pass, and band stop filters. All right, let me end this session here. In the next session, we will do the design of a FIR filters.